Hi friends, welcome back. So in the previous session, we are seeing DFT topic. Still we are in the DFT topic. So one property that is nothing but the concept what we have seen is circular shifting. Now time shifting property. What is the time shifting property? Time shifting property. Time shifting property. What is the time shifting property? Suppose let's say x of n having x of k. X of n minus n naught. N minus. Then what is the DFT for this? Is I told you shifting in one domain leads to exponential multiplication. So x of k, here the exponential is e power minus j 2 pi by n k n naught. This is also can be written as x of k e power minus j 2 pi by n as middle factor wn power k n naught power k n naught. That is the way we can. Next, there is a very important thing, that is x of n minus n by 2. Suppose half of the period if I shift it, half the period if I shift it, then this is nothing but x of k e power minus j 2 pi by n into k into n naught, that is nothing but n by 2. So n get cancelled, 2 get cancelled. Finally this is e power minus j pi k, so which is nothing but minus 1 whole power k x of k. So this is very important. Suppose if I shift it half of the period, this is the result we are going to get. Clear? Take this question. So here x1 of n having DFT x1 of k, x2 of n having DFT x2 of k. Then what is the relation between x1 of k and x2 of k? So to find the relation between x1 of k and x2 of k, first we have to see what is the relation between x1 of n and x2 of n. So from that we can say what is the relation. So let's say, because it's a 4-point DFT, because n is equal to 4, this is a 4-point DFT. 4-point DFT. If you observe carefully, last 3 digits we have written in the front. That means it is nothing but x2 of n is same as x1 of n minus 2. X1 of n minus 2. That implies this is x2 of n is equal to x1 of n minus 4 by 2. That is this result we are going to get. So now DFT, if I take DFT on both sides, x2 of k is nothing but minus 1 whole power k x1 of. So this is the relation between x1 of k and x2 of k. Clear? Take it. So let's see what it is. And it is a 6-point DFT. 6-point DFT. How did I say that? Because of the twiddle factor. But still, we don't have to worry about anything just because it is a simple properties what we are applying. How we can solve this? So if you see this relation, so I can write because given y of k having a relation x of k multiplied with w6 4k. So what is y of n then? Which is same as x of n minus 4 because n naught value is equal to 4 because n naught is equal to 4. So once we got this one, then how we can calculate x of n minus 4? We have to take last 4 digits and we have to write them inside. So what it is going to be? 2, 1, 0, 0, 4, 3. So this is what y of n. Yes. Okay. Next, frequency shifting process. Frequency shifting process. What is this frequency shifting process? Try to understand. Suppose x of n having DFT x of, then I told you shifting in one domain leads to exponential multiplication in the other domain. So I want to get frequency shifting means in the time domain it has to be exponential multiplication. Then with what we have to multiply? So x of n is multiplied with e power j 2 pi by n k naught n k naught n. Then it is x of k minus k naught. This is the one property. Next, suppose I want to get x of k minus n by 2 half of the series. So here, if k naught is equal to n by 2, n get cancelled, 2 get cancelled, pi n, which is nothing but minus 1 whole power n, minus 1 whole power n x of n. So this is having DFT, which is x of k minus n by 2. Clear? Take it. Based on this frequency shifting property, one example, if x of n is equal to 1, 2, 3, 4, then find inverse DFT of x of k minus 1, x of k minus 1. Yes. First of all, DFT they are talking about is a 4-point DFT. Implies capital N is equal to 4. Capital N is equal to 4. See here, for x of k, we are having inverse DFT small x of n. For x of k minus 1, what is the inverse DFT? That is x of n e power j 2 pi by n. N value is equal to 4 and k naught value is equal to 1. So this is equal to x of n e power j pi by 2 n, j pi by 2. So now how we can calculate this one? So let's say n is equal to 0, then it is going to be e power j 0 x of 0. Come. If n is equal to 1, then it is e power j pi by 2 x of 1. Come on. If n is equal to, let's say, 2, then it is going to be e power j pi x of 2. If n is equal to 3, then it is e power j 3 pi by 2 x of 3. So this is what it is. Okay. Let's see one by one. What is e power j0? That is nothing but 1. So what is x of 0? Same 1. Next, e power j pi by 2. What is e power j pi by 2? Cos pi by 2 0, j sin pi by 2, that is nothing but j. J x of 1, that is nothing but 2. Next, e power j pi, which is nothing but minus 1. So minus 1 into x of 2, that is minus 3. E power j 3 pi by 2, that is nothing but minus j 4. So this is what the signal what we are going to get, inverse DFT of x of k minus 1. Clear? Here is that. Time reversal. What is that? Suppose x of n having DFT x of k, then x of minus n having DFT x of minus x of minus. Let's solve one example. DFT of x of n is x of k is equal to 10 2 plus j2 minus 4 2 minus j2. Here is that. Then obtain DFT of x of minus DFT of x of minus. So we know from the property x of minus n having DFT, which is x of minus. If you observe carefully, x of k is also periodic signal. So if it is a periodic signal, then we have to use circular shifting property. That means to calculate x of minus k, keep the zeroth position as it is and write the remaining samples in the reverse order. So that's what we have to do now. So it is nothing but then reverse order. 2 minus j2 minus 4 2 plus j2. So this is what we are going to do. Clear? Take it. Some more properties. Convolution property. So in time domain it is convolution, but here we have to use a separate name which is nothing but circular convolution. Why? Because in the time domain the signal what we are considering is a periodic signal. I told you whenever the convolution between two periodic signals happens, then that convolution is called as circular convolution. So circular convolution property we are talking about now. So what is circular convolution property? In time domain, x1 of n circular convolution. So this is the symbol for circular convolution. x2 of n. Then what is the DFT for that? This is x1 of k multiplied with x2 of k, x2 of. Next, in the similar manner, product property, which is a circular convolution in frequency domain. Product property. What is product property? Suppose x1 of n multiplied with x2 of n. Then what is the DFT for this? This is 1 by n x1 of k convolution with x2 of k. But this convolution is also circular convolution. Why? Here x1 of k and x2 of k is also periodic. So I can say x1 of k circular convolution with x2 of k. X2 of. So these are the properties. Next, Parseval's theorem. What is Parseval's theorem? Summation n is equal to 0 to n minus 1 mod x of n whole square is equal to 1 by n summation n is equal to k is equal to 0 to n minus 1 mod x of k whole square mod x of k whole square. So this is the Parseval's theorem you have to remember. And last property we are having is central ordinate theorem. Central ordinate property. What is a central ordinate property? First, let's say we know that x of k is equal to summation n is equal to 0 to n minus 1 x of n w n power k n. Now, suppose I want to get capital X of 0, x of what we are going to get? Capital X of 0. This is k value 0. This value will become 1. Then summation n is equal to 0 to n minus 1 x of. So those samples we have to sum. And here one important property which is x of n by 2, that k value is equal to half the period. Then what will happen? This will become k is equal to n by 2. So it is going to be minus 1 whole power n. So summation n is equal to 0 to n minus 1 minus 1 whole power n x of. That is what we are going to get. Similar to this, suppose x of n, if I write 1 by n summation k is equal to 0 to n minus 1 x of k w n power minus k minus k. So here also the same property. Suppose if I want to go for n is equal to 0, then this value will become 1. 1 by n summation k is equal to 0 to n minus 1 x of x of. In the similar way, x of n by 2, then this is 1 by n summation k is equal to 0 to n minus 1 minus 1 whole power k x of. So these are the central ordinate properties. Take it. If x of k is equal to then this is actually DFT of x of n. Then find DFT of find DFT of x of n minus 2. So first this is x of n minus 2, then we will see the remaining one by one. X of n minus. So first of all, it is a 4-point DFT. 4-point DFT. If it is a 4-point DFT, so we are having n is equal to for x of n minus 2. So what is the DFT we are going to get? Because it is equal to x of n minus n by 2 having minus 1 whole power k of k. So I already told you, whenever if it is multiplied with minus 1 whole power k, then 0 is a positive alternate minus plus minus. So finally we are going to get 4 j2 0 minus alternate plus minus like that we are. Next we are having one more property which is nothing but conjugate property. So here I am mentioning conjugate property. What is a conjugate property? If x of n having x of k is the DFT, then x conjugate of n, what is the DFT of this? X conjugate of minus x conjugate of minus. Let's suppose second question, if they ask find the DFT of x conjugate of n, x conjugate of. So if it is x conjugate of n, it is going to have DFT. Just now we have seen x conjugate of minus k. So first x minus k. How we can do that? It is in the reverse order. So 4, keep it there, j2 0 minus j2. For this we have to take the conjugate. So this is going to be 4 minus j2 0. Same thing we are going to get because it is a real signal. Okay. Third one, find the DFT of x of minus n. For x of minus n, what is the DFT? So from the time reversal property, this is going to be x of minus. So what is x of minus k? So this is simply reverse order 4 j2 0 minus. So this is what the DFT. Yes, take it. Example, if x of n is equal to 1 minus 2 3 minus 4 5 minus. Then find first question, capital X of 0. Second question, summation k is equal to 0 to 5 x of k. Third question, capital X of 3. Capital X of 3. Fourth question, summation k is equal to 0 to 5 mod x of k square. The question, sum of summation k is equal to 0 to 5 minus 1 whole power k x of. These values we have to calculate. So a signal x of n is given. We have x of k. So in that k is equal to. So what we are going to get first? This is a summation, because it is a n is equal to 6. 1 2 3 4 5 6. N is equal to n is equal to 0 to 5 x of 1 minus 2 plus 3 minus 4 plus 5. You are going to get, I think, minus. The answer is minus. Next, to get this value, what is this actually? So if 1 by n is there, 1 by 6 is there, then it is a small x of 0, but it is not there, so it is nothing but n x of 0. N value 6. What is x of 0 value? That is 1. That is going to be 6. Next, x of 3. What is x of 3 actually? X of n by 2. X of n by 2. What is x of n by 2? Summation n is equal to 0 to 5 minus 1 whole power n x of n. So what we are going to get? So summation minus 1 whole power n means at 0 we are having positive, minus, positive, minus, positive, minus. So minus means we have to take minus here, minus here, minus here. Then it is going to be plus 2, plus 4, plus 5. So we have to add them. 1 minus of minus 2 plus 3 minus of minus 4 plus 5 minus of minus. So how much you are going to get? 21. Next, from the partial theorem, suppose if it is 1 by n, then it is summation x of n square. So if it is not there, so it is n summation n is equal to 0 to 5 mod x of n square. So what is that? 6. 1 plus 4 plus 9 plus 16 plus 25 plus 36. You are going to get 546. 546 is the answer. Next, this one. Summation k is equal to 0. So I told you this is similar to that of suppose we are having minus, sorry, 1 by n is there, then it is x of n by 2. So if n is there, if n is not there, small x of n by 2. So that is 6 x of 3. 6 into, what is x of 3 value? 0 1 2 3 minus 4. So this is minus 24. Clear or not?